Hello, my name is Prisha, and today we're going to be learning how to read and interpret graphs. I'll be covering some of the basic features of graphs, such as the x and y intercepts, the slope of a graph, and the axes or units of measure of a graph. I'll also be covering the different types of graphs, including how to identify them, common things you'll be asked to do with them, and tips and tricks to account for. Finally, we'll be doing a bunch of examples to practice all of our new skills. Let's get started. So, what are some of the main features of a graph that you need to be aware of? The first are the axes. The x-axis, or a horizontal axis of a graph, usually has the independent variable value, meaning the variable that is being changed at regular intervals. The y-axis, or vertical axis of a graph, usually has the dependent variable, or the variable that's being impacted by changes in the independent variable. When you find your answer, you must pay attention to the units of the variables that the question is involving in order to get the question right. For example, if the question is asking me about the year that the cumulative percentage change in AGTB is -6, I would draw a line from that known percentage, and then I would find where that point has what year that point is, the point I intersected with that line. And that would be 2 years. And I need to make sure I say years because that's the correct unit of what the question is asking me. The next thing to know is the intercepts. The x-intercept is where the graph crosses the x-axis or where the dependent variable is 0. For example, this graph doesn't seem to have an x-intercept because even if I continue on this line right here, I don't see any point that it would actually hit the x-axis. The y-intercept is the same concept, just with the y-axis and with the independent variable being 0. This graph does have a y-intercept. When the independent variable of the year is 0, the dependent variable of the percentage change is also 0. Lastly, we also want to know what slope is. The slope is the change in the dependent variable over the change in the independent variable, and it can be calculated over an interval or over the entire graph. You can think of it as rise over run, or the amount the graph has changed vertically over the amount the graph has changed horizontally. It can be calculated for the entirety of a linear graph with just one calculation, but with this curved graph right here, slopes are mostly going to be done on specific intervals in order to more correctly estimate values in between. So if I wanted to graphically calculate the slope from 2 to 3 years on this graph, I would calculate the amount it's risen, which is actually -4 because I see that we're going from -6 to -10, which is a decrease in 4 units, and the amount the graph has run, which is 1. So I can write in those values right here. And if I divide that rise over the run, I'm going to end up with a slope of -4. Time to move on to types of graphs. This is a line graph, or one of the trickier graphs you'll encounter on the ACT or SAT or any test really. It's essentially a line plotted on 2 axes. There's always one independent variable and one dependent variable, but for example, like in this graph, the graph can be layered on top of each other. So there's the same independent variables in both graphs, but what's happening is that we have one graph with the dependent variable of the monthly average cover of middle clouds, and one graph with the dependent variable being the RCRF. So what we actually see in this graph is for each year we have 2 dependent variable values that we can keep track of. And what this question would mostly ask, and guesstimating what this question would ask us to do, it would probably ask us to do something to figure out something like the relationship between both of these lines. The test will usually ask you to identify values on this graph, determine whether the graph is increasing or decreasing, which is easy. It's increasing if the graph goes up so like in this section right here, and it's decreasing if it goes down, like in this section here. And you'd also want to determine where the rate of change is the highest or lowest. Basically, it means the steeper part of the graph means that it has a higher rate of change, and the shallower part of the graph means that it has a lower rate of change. If you can imagine that you're taking the slope of a specific interval, so let's say this interval, the average rate of change is basically the slope, but the absolute value of the slope. We're disregarding the sign. The next graph you might encounter is a bar graph. It's relatively a very easy graph compared to a line graph and has the same structure, except for some cases where the independent variable doesn't increase. I mean, this one is where the independent variable increases, but you could also have a bar graph where your independent variable is just separate categories. Like, say, if your independent variable was animals, you could have one that it's like cat, one that's dog, one that's dolphin, so on and so forth. So you don't always have to have like a linearly increasing independent variable. So the size of each bar will obviously correspond to the quantity, and questions will usually ask you to use data straight from the graph. So make sure to double check the information that the question is giving you in order to end up at the right answer. For example, if it's saying like a certain year and what the average beak depth was in that certain year, then you want to make sure that you're having the correct year in the first place, because if you mess that up, then you're going to end up getting the question wrong. No matter even if you picked another year and chose the correct average beak depth for that year. So you always have to be very careful with bar graphs, even though it's very easy. The scatter plot is also a lot like the line graph, but in this case, you'll be making guesses about any data points not already on the graph. If the question asks you about a value not present, you're going to want to draw a line through all the points that kind of goes with the flow of the graph. You could probably draw it a little bit better than me, but what you can do here is that if that question asks you, what's the average cumulative percentage change in AGTV at the 2.5 year mark, you can kind of guesstimate that it's around 8, just based on this curve. But you have to remember that this is an estimate. It's not going to be completely 100% accurate. So in your answer choices, you may also have error there. Other than that, all the other calculations are exactly the same as line graphs. If the question asks you about where the graph is steepest or where the average cumulative percent change is changing the most, you'd obviously want to go for where the absolute value of the slope is the most, and everything else is pretty similar. So now we're going to do some tricky graphs just to test our skills from the previous 3 types of graphs that we learned. So you'll encounter a couple of graphs like these where you'll never have seen them before. It'll kind of just be new territory, and what the ACT or SAT or whatever test is relying on is that you can use the skills from those previous basic graphs and apply them to here. So for this first question, we have, which of the following absorb the most light across all wavelengths? So basically we have this graph where we have wavelengths that are increasing, we have reflectance, and this is all laboratory data. And I'm presented with 4 answer choices. I'm trying to find the one that has absorbed the most light. So when I see the word reflectance, I think that's the opposite of absorption. So I'm trying to find probably the line that has the least amount of reflectance, and it should be applicable for all the wavelengths. So if I look, then I think brown S is actually the perfect answer here, because for all wavelengths, its reflectance is less than every single other thing. So that's what I'm going to circle. Okay, now the next question. Which of the following would most likely not be found at a pressure of 10 kb? So I don't need to know what kb is. I don't need to know what actually any of these variables are, because usually the ACT or SAT or whatever your test you're taking will not ask you to convert between variables unless it's very, very well known what that conversion is. So don't stress about understanding what some of these variables are. But for the question, which of the following would most likely not be found at a pressure of 10 kb? So even though I don't know how exactly these sections work, I'm assuming that each section pertains to an area where that facies would be seen. So we're trying to find a facies that cannot exist at this 10 pressure mark. So if I draw a line through all of these, and I go all the way to here, I can see that facies C, G, and E, which are answer choices here, they're all like, they might hit 10 kb, but I know facies A, which is also an answer choice, it's never gonna hit 10 kb. So that's what I'm gonna pick. And you wanna make sure that you pay attention to the wording of the question. It said not here. If you had interpreted it as yes, it would be found at a pressure of 10 kb, you'd get into the messy situation of trying to speculate whether facies G or E are even in the 10 pressure line. So make sure you read the question. Don't not read the question and then just spend more time getting stuck with the answer choices. Okay, now we're going to move on to some examples, some things that you'll most likely see on the SAT or ACT or any test math section. So Chris lives in Omaha, Nebraska. He works in regional sales and has to travel throughout the week to meet with clients. The graph shows the distance that Chris's car is away from his home over a period of time in a given week. Which of the following situations best fits the information recorded in the graph? Okay, so for this, I'm probably just going to interpret the graph separately and then pick the correct answer choice. I'm not going to go through all these answer choices because that's probably going to take a while. So I see that Chris starts already away from home, so he's already somewhere. And then he goes further away from home for a bit until Monday. And then he seems to stay at that mileage, so it seems that he's like staying at that place. And then on Wednesday, he's going to return home. So let's pick the answer choice that corresponds to that. So I'm looking at all of these, and the first thing I see is Chris leaves one of his clients or Chris leaves home. So D and E is one block, and C, B, and A are one block of answer choices. So I'd pick that Chris leaves one of his clients because if he leaves home, he would start at 0 miles, but in this case, he's starting at 200 miles, which means that he's already somewhere. So I can eliminate D and E right off the bat. I can also see that I have the option that he drives to another client or he drives back home. In this case, I think he drives to another client because if he drove back home, he'd end up at 0 miles sometime close to this time, which he doesn't. He seems to go to another place, stay there, and come back. So I think that C is out because he's not driving back home, so I can eliminate that. And then the last part, he either stays there a few days and returns home, or he drives back home. Well, this flat section has to be accounted for, so I think he stays there for a few days, because that's why he's not moving. So I think the answer here is A. Okay, next example. A probability and statistics class conducted a dice rolling experiment. Each trial of the experiment consisted of rolling a single, fair, six-sided die 6 times and counting the number of threes that resulted from each roll. The class recorded the results of 100 trials in the graph. In approximately what % of trials did the class roll threes more than 2 times? Okay, so basically I'm trying to count the number of trials where we're having 3 and above threes per 6 rolls. So in that case, I'm just going to add up all of these bars, and that should give me my percentage because all of this should add up to 100%. So I have 10% for 3 times number of 3s per 6 rolls. I have around a little less than 5 for number of 4 times of 3s per 6 rolls. And I have a little bit less than 4 but under 5 numbers 5 3s per 6 rolls. That's hard to explain. So we'd have 10 plus like something under 5 and something under 5. So like let's say 5. I'd guesstimate this. So what I see in these answer choices, definitely not going to be A, B, or C, because what happens is that we already have 10% here. It can't be 3, it can't be 5, it can't be less than 10%. And it seems, and 4 and 5 do have some trials, so it can't be exactly 10%. Also, 85%, that's way above 10. There's no way that these small amounts add up to a full 75% more than 10. So I think D is the correct answer here. Even though I couldn't very exactly pinpoint 15%, even though I did kind of guesstimate it, I got lucky. The fact that these answers are all way out of the ballpark clues me into the fact that it would be D. Okay, that's all. Thank you for listening and have a wonderful day.